All right, here are the examples from section 1.7. The first one is number 1, and I can see because of the square roots, I'm going to try the rationalizing trick. Direct substitution will not work. It's going to give me a 0 denominator. So I automatically know I've got to do something to this. Well, here's the something. You're going to multiply it by what's called the conjugate. And you get that by taking this ugly square root thing, x plus 7 minus the square root of 7. But see how this one's minus? You want the opposite sign here. So that's going to be a plus. And it has to be equivalent to 1 because you're not allowed to change the value of the original fraction. So that's going to make this the square root of x plus 7 plus the square root of 7. Because this is equivalent to 1, it's just different looking. It's a funny looking 1. And we're going to see, that makes it a valid math move, right? So we're going to see what happens if I take and multiply these things together. The limit hasn't changed, it's still going to 0. But here's where foiling is going to take place. All right, firsts. The square root of x plus 7 times the square root of x plus 7 is x plus 7. It gets rid of the square roots. The square root of x plus 7 times a positive square root of 7 is a positive square root of 7, square root of x plus 7. The inners give me a negative square root of 7 times the square root of x plus 7. They knock each other out. All right, so you don't have any inner terms for this thing. And then you go to the last. Negative square root of 7 times a positive square root of 7 is a negative 7. And all of this is over the denominator. I can't do anything better with that. It's just going to be kind of ugly for a minute. X on the outside, x plus 7 plus the square root of 7. So I just took the two pieces in the denominator and put them together. And then I'm going to see how that changes things. How, if there's stuff that I can cancel out. And you can see the 7s actually. They're gone. Which leaves me the x on top with the x on the bottom. They're gone. And so what I want to know for sure is what's the limit as x approaches 0 of 1 when everything cancels out, it's a 1, over the square root of x plus 7 plus the square root of 7. And then the hope is when I try doing direct substitution now, I'm going to get an answer. And so that's the deal. So I'd plug the 0 in, I get the square root of 7 on the bottom, another square root of 7. How many square roots of 7s do you have? You got 2 of them. So 1 over 2 square roots of 7 is your final answer for that guy. So again, this is all about algebraic manipulation. In the last couple sections, you were looking at doing it with factoring techniques and such. This section, you're looking at doing it with this rationalizing using conjugates and complex fractions. All right, that's it for that page. We're going to go to the next page. And the next one I picked was number 6. So if you're looking at number 6, I'm trying direct substitution, always the first try. Gives me a 0 denominator, and you're like, oh, okay. So I'm looking at this. There are no roots. So the trick of the conjugates that we just looked at, we're not going to use that for this because there's no roots. So you can't come up with a conjugate. So there must be something else that I can do. And if I look at this one, oh wow, I can factor out an x on the top. Let's see how many x's I can really factor out. You're allowed to take the lowest power that they have, so I can take out an x to the 4th. That makes me do a happy dance because I have an x to the 4th on the bottom that I can bang those two out of there. And now I'm really just looking at what's the limit as x approaches 0 of 2x plus 3. Plug it in, 0 in there. Direct substitution gives me an answer of 3. That one's an easy peasy one. I should have left that for you, right? The reason I like that one to do is because, remember, as you're going along, don't forget the old rules. They still are in play. So in a section where they're predominantly trying to make you think of conjugates and complex fractions, they're going to give you ones from other sections that you've previously learned. So don't be afraid to try to use some of those techniques. All right, number 7 is next on my list. 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 Number 7 is next on And I see this as the complex fraction. So again, I tend to go horizontal with it. And what I'm going to do is I'm going to write it horizontal first. This is probably going to take me more than what the box is going to give you. Like I'm probably going to go outside the box in the writing of this because there's a lot of steps. But that's okay. So limit as x approaches 6 of x over, so x divided by. I'm looking at this and wondering, will direct substitution work on, will it give me a 0 denominator down here? I did this whole, let me show you, well, kind of show you. I did this whole thing getting common denominators. But as I'm looking at this with direct substitution, if I put a 6 in here, that'll be 1/12. And 1/12 minus 1/6 does not give me a 0 denominator. So I think we could do this one. We're going to try this one 2 different ways. Let's try it with direct substitution and see where I'm going to go up above the box for this. So that's going to give me, I'm still going to go horizontal with it. X approaches 6 of x divided by, and if I directly substitute this in, it's going to be 1/12 minus 1/6. 1/12. Well, if I think about what that would be, 1/12 minus 1/6, it's going to be, and this was a 6, I can substitute that in too, right? So it's 6 divided by, if I make these twelfths, it's 1/12, and I've got to multiply by 2 over here. So that's going to be 2 twelfths, so minus 2. If I do 1 minus 2, it's a -1, so what I really have is 6 divided by a -1/12. And remember, you, what is it, keep, change, flip, or something like that you guys called it? So I keep the 6, I change to a times, and I flip the 1/12 into a -12 over 1, and I get -72, and that really is the answer. But for the fun of it, getting common denominators, in this, let's try it the other way, the way that I originally did it. I didn't use direct substitution. It still is going to give you the same answer in the end. So it's kind of cool that you can do it a couple different ways and still end up with the same results. So if I were to not realize that I could use that, here's what it would look like. It's going to be x divided by 1 over x plus 6 minus 1 over 6. And so all I'm doing is separating it out because of the complex fraction, making it go horizontal. So when I'm looking at this, it's the limit as x approaches 6 of x divided by. Now this grouping, you need to have a common denominator. So the common denominator has to have one of each piece. You've got an x plus 6, and you've got a 6. And then you need to match. So this guy has the x plus 6 part, he doesn't have the 6. And so in order for him to have a 6, I need to multiply my numerator by that 6. So this becomes a 6. And then I have a subtraction sign. And the second fraction has the 1 over 6, it needs the x plus 6. So this one I'm going to multiply by x plus 6 over x plus 6. When I do that, that's going to give me, now I'm going to keep this with parentheses because I know I've got to distribute that negative. I've got a couple pieces coming at me. So it's going to be negative x, well, it's going to be x plus 6 that I'm going to distribute that negative to in just a second. So then I clean it up. Okay, now I'm still, next step, same thing. And yes, you need to keep this notation every single time. Limit of x divided by, how can I make this better? Let's think. I have 6 minus x minus 6. My 6's are going to cancel. And I'm going to be left with a negative x over 6 times x plus 6. All right, I'm ready to do my keep, change, flip. So I'm doing the limit as x approaches 6 of x times, a little bit over, negative x here, 6 times x plus 6 here. The x's cancel, and I'm left with a negative 1 on the bottom. So let's do a direct substitution now. It'll be 6 times 6 plus 6 over negative 1. 6 plus 6 is 12. 12 times 6 is 72. Over a negative 1 is a negative 72. And the reason I wanted to show you that, even though we did it the first way, is because there's going to be some problems where you need to do that. There's a whole lot of math going on in the midst of trying to find those common denominators and such. So you really need to remember how to do those from back in the day. We are going to try one last one. Questions on that though, number 7. Any parts of that? I mean, there's a whole lot to that. So questions, anything there? Lots of places to make little mistakes, right? So just be careful. Be careful in the midst. All right, number 13. Last one. Lucky 13. This one, again, I'm going to go horizontal with this thing. So if I look at it, again, this one's going to be more work probably than it's going to fit in the box. But if I do direct substitution, I have the 0 denominator. So for this one, it wouldn't. Direct substitution is not going to work. Limit as x approaches 0. If I go horizontal, I am 1 over x plus 2 squared minus 1/4 divided by x. So I need to get common denominators in my parenthesed part. The limit as x approaches 0. All right, so to get that common denominator, I'm taking one of each piece. So I need a 4, and I need an x plus 2 quantity squared. Then I'm matching. This guy has the x plus 2 quantity squared. It needs the 4. 4 times 1 is 4. Minus. This guy needs the, he has the 4, he needs the x plus 2 squared. So he's going to be x plus 2 squared. And then divided by x. All right, so if I take this thing and I FOIL out the top, you see how this has a 4? What do you think is going to be your last term for this piece when you FOIL that out? And you say a 4, right? So you're going to be able to cancel out this 4 with that 4 if I FOIL this out. So you're kind of thinking ahead. You're thinking ahead, okay, here I am, I'm looking at this. That doesn't look pretty, and that doesn't look like it's going to help me any. So I've got to think ahead a little bit and realize that if I do FOIL this out at the top, don't FOIL it out on the bottom yet. We're going to talk about that in a minute. But if I FOIL it out on the top, I can see this 4 will end up canceling. So that's what I want to do next. So I'm going to do the limit as x approaches 0 of 4 minus, let's think about what this would be. I'm going to kind of squeeze it in here. Let me do it in a different color. So if I FOIL this, it's x squared plus 2x plus another 2x plus 4x plus 4. But I'm distributing the negative to that. So it's really going to be this 4 minus x squared minus 4x minus 4 all over 4 times x plus 2 quantity squared and then divided by x. Now you're probably going to say to me, how come it is you're not FOILing the downstairs guy? And the reason is because, is it going to cancel anything out? Is it going to do any good for me to do that? And it isn't necessarily yet. Maybe it will in the next step, but for now, that's not going to do me any good. So I'm going to just leave it the way it is. Is it wrong to FOIL it out? Absolutely not. It's just more algebra steps than you really need to take. So I'm trying to conserve on those if I can. Here I go. Let's see what we got. 4's canceling. All right, limit. We're getting close, kids. As x approaches 0 of negative x squared minus 4x over 4 times x plus 2 squared. I'm going to take in my keep change flip times 1 over x. And again, I'm thinking ahead. Now what can I do? Because I still have a zero denominator thing going on that's going to mess this whole thing up. If I do direct substitution, I'm just not there yet with an answer for this guy. But do you notice the next step? If I were to take this guy and factor out an x or a negative x, because they both are negatives, whichever way you want to go, it doesn't really matter, then I could cancel it with this guy that's down here. And then I won't have that zero denominator problem anymore. So I'm going to take this guy and I'm going to factor out a negative x. Well, if I take out a negative x, I'm just going to do it up above here again. I'm going to go red penning. If I take out a negative x, because I'm running out of space to be able to show you the steps. All right, negative x, that's going to give me an x plus 4. Well, this negative x can cancel with this guy on the bottom, and that's going to finally give us, if we come way down here, the limit as x approaches 0 of a negative on the outside, x plus 4 on top, a 4, and an x plus 2 squared on the bottom. And I'm going to try a direct substitution and see if that'll get me finally an answer for this monster. All right, 0 plus 4 is 4, negative 4 on top. 0 plus 2 is 2, 2 squared is 4, and 4 times 4 is 16. And so my final answer is negative 4/16 or negative 1/4. All right. Anything on anything that I can clear up for you? That was a hard problem. You can see there's a lot of steps, and I know you can do it because I know you've got all those algebra skills in you. But questions or problems on any of that?